Thank you for joining me. I'm glad to have you. Today I want us to look at refraction of light waves. Now we start with the definition of term, refraction. Refraction simply means a change in the direction of light when light crosses the boundary between two transparent media of different densities. Or you can say it is a bend in the direction of light when light crosses the boundary between two transparent media. For example, assuming we have this as boundary between two media. Let's say here is air and here is water. So if we draw a straight line, which is a normal line, incident to light, and of course this light, this is the boundary between air and water. On getting to this point, the direction of the line will change. If it changes, automatically an angle is formed between these rays. Of course, this is the refracted ray, while this one, incident on the glass, is the incident ray. Now, between this normal and this ray, an angle is formed there. That angle is known as angle of incidence, while here is angle of refraction. Now, between the glass, between the incident ray and the boundary, let's say if here is glass, here is a glass block. Now we have here as our glance. This is the angle of glance. Now, if we continue this, assuming this line, this incident ray is continued. If we continue this incident ray and then we come like this, an angle is formed somewhere here. This angle is known as an angle of deviation. Now, if we have here as our angle of deviation, we can always get our eye. If glance is given and eye is not given, of course, this is 90 degrees. So if we want to get eye, angle of incidence is equal to 90 degrees minus angle of glance. Now, this ray, this angle here, angle of deviation, if we want to get the angle of deviation, of course, the angle of deviation is angle of incidence minus angle of refraction. Therefore, deviation is angle of incidence minus angle of refraction. So these two are important. Now, having discussed this, we can move straight to give the laws of refraction. Of course, there are two laws of refraction, as we said earlier in our earlier video where we discussed reflection. We said the laws of reflection, there are two laws of reflection. The same thing is applicable to this one. There are two laws of refraction. The first law says that the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. That is the first law. Now, the second law of refraction states that the ratio of the sign of angle of incidence to the sign of angle of refraction is a constant for a given pair of media. So we now have, since the second one, of course, that second one is always called Snell's law. So the second one is called Snell's law. Snell's law. Now that Snell's law is ratio law, where we have that sine I all over sine R is a constant for a given pair of media. And of course, that constant mu is known as the refractive index. So we can now say that, yeah, this is we have established that mu is equal to sine I all over sine R for a given pair of media, where mu is the refractive index. Mu is the refractive index of the material, of the medium in question. Now, this is water, The refractive index of water and the refractive index of glass are not the same because they have different densities. So now it is worthy to note that refraction occurs when light travels, when light crosses the boundary between two transparent media of different densities. For example, if light crosses from air through water or air through glass, it can still move from air to any medium, any transparent medium. It can be from air to oil. So the moment that light gets to the boundary, it bends away from the original direction. Okay, so we have sine I over sine R is equal to mu. Generally, mu is equal to 1 over sine C. 1 over sine C. This is another formula for the refractive index. Mu is equal to 1 over sine C, where C is the critical angle of the medium in question. For example, of course, you know that angle of incidence and the R, they work hand in hand. And of course, 1, 2, 3 are dependent on each other, because especially these two depend on I. As you increase your angle of incidence, angle of refraction will be moving away from this normal line. So if you increase this one, let's say by 5 degrees, this one will increase. As you shift I, R will continue to increase until it gets to a point where this refracted ray will fall on this line. Now, once it falls on this line, the next thing is for it to go back. Now, that point, that particular angle of incidence for which angle of refraction will now fall on this one is what we refer to as a critical angle. By our next video, we will discuss more on critical angle, but just have it in mind that critical angle is that particular angle of incidence for which angle of refraction will give us a 90 degrees. So, now, if light travels through liquids, now refractive index of light of the medium will give us the sine of angle of incidence in air all over sine of angle of incidence in medium. For example, we can have this if it travels through glass, from air to glass, we now have the sine of angle of incidence in air all over sine of angle of incidence in glass. Or if it crosses through boundaries between air and liquid, any liquid, it can be petrol, it can be any liquid. So here we have water. So speed of light will be here. And of course, you know, once it crosses once it gets to that boundary, that interface, speed changes. Two things changes there: the speed and that of the wavelength. So we now have that, yes, speed of light in air all over speed of light in water. We also have the formula that says refractive index is equal to wavelength of light in air all over wavelength of light in water. We have one that says real depth all over the apparent depth is equal to the refractive index. So this thing here, we can still say that this one, we can still say mu is equal to velocity of, sine of angle of incidence in, we can say is sine I all over sine R. Here we can say mu is equal to velocity of light in air all over the velocity of light in water or in glass, as the case may be. But for this one, this is water. If it is glass, you will put glass here. Now, if we want to express it in terms of wavelength, we can say mu is equal to wavelength of light in air all over the wavelength of light in water or in glass, as the case may be. This one can still be represented as mu is equal to real depth all over the apparent depth. apparent, you can say APPD, apparent depth. Now, this apparent depth, most times, apparent depth may not be given. But if the apparent depth is not given, of course, you cannot have that apparent depth is equal to real depth minus the displaced depth. This displaced depth can as well be known as the lateral displacement. For example, if you view the swimming pool vertically, swimming pool appears shallower when you look at it vertically than it actually is. So that is because the real depth has been displaced laterally. So that is why we have the apparent depth is equal to real depth minus the displaced depth. That will give us the apparent depth. So let us take one or two calculations. We have as many calculations as possible we can take to let us better understand this problem. Okay, number one. A beam of light is incident from air to water at an angle of 30 degrees. Find the angle of refraction if the refractive index of water is 4/3. If the refractive index of water is 4/3. So we can now have this. So from the question, they say a beam of light is incident from air to water at an angle. That means angle of incidence is 30 degrees. Then we are meant to find the angle of refraction, given that mu is 4/3. Now, the first thing we do is to employ which of the formula will suit this. Remember, these formulas we have there, plus one that I've already claimed, they are there to help us to solve the refraction problem. So we have that mu is equal to sine I all over sine r, which will give us mu, which is 4/3, is equal to sine I. Sine I is 30 all over sine r. Now at this point, we can cross multiply. If we cross multiply, we can now have 3 sine 30 is equal to 4 sine r. Now make sine r resolve the sine r is equal to 3 sine 30 all over 4, which will give us 3 times sine 30 is 0.5 all over 4. Now 3 times 0.5 by calculation, 3 times 0.5 will give us 1.5 all over 4. And this divided by this will give us 0.375. Remember, this is a sine r. That means sine r is equal to this. We're not looking for sine r, we're looking for r. R is the sine inverse of 0.375. R will give us, from our fourth figure table, it will give us 22 degrees. So the angle of refraction there is 22 degrees. Okay, we take the second question. The second question says, water is poured into a jar to a depth of 24 centimeters. The bottom of the jar appears to be raised by 6 cm when viewed vertically. Calculate the refractive index of water. Calculate the refractive index of water. Now we have this. This is the jar. Assuming this is our jar. We have the jar like this. We'll have this. Now from the question, they said the depth of the jar is 24 centimeters. Now when you view through when you view vertically, the bottom of the jar appear to be raised by 6 centimeters. Remember, it appeared to be raised by 6 here. This one is still part of this. This side, which is the apparent, the displaced depth, is not there. Now, how do you find the displaced depth or the lateral displacement? Of course, from our formula here, we said that apparent depth is equal to real depth minus the displaced depth. So, which will give us the apparent depth here now. Apparent depth is equal to real depth minus displaced depth. Which real depth is 24 from here, minus the displaced depth. It has been displaced by 6, which will now give us 18 centimeters. Okay. Now this is our apparent depth. This is our real depth. Our formula says mu is equal to real depth minus all over the apparent depth. The refractive index will now give us mu equal to 24 all over 18, which will give us 1.33. And of course, the refractive index does not have SI unit because this one is in centimeters, this one is in cm. So cm will cancel out cm, leaving us with 1.33. Okay. So we'll still take another problem. This one says, a ray of light is incident at an angle of 30 degrees at an air to glass interface. Question 1. Draw a ray diagram to show the deviation of the ray in the glass. Second question. Determine the angle of deviation if the refractive index of glass is 1.50. So we now solve this problem. Now, for us to solve the problem, remember, is a diagram problem. So we draw the diagram first. Now, this is the diagram, a diagram of a glass block. Now, this diagram of glass block. Now, this is a normal. Now, let's draw the diagram to represent it. So we can put down this is our, if you continue the line, incident. Now remember, we have we can use dotted lines here as this is our refracted ray. This is our refracted ray. Now this is angle of refraction. This side is the deviation in question. Now this is angle of incidence. Angle of incidence from the question is 30 degrees. So they say calculate D. Now we can have I is 30 degrees, R is not there, and then D we are looking for the deviation. But remember the question says, the formula says for us to get our deviation is equal to I minus R. So I minus R will give us, all we need to do is to find R. How do you get R? Use a formula that says mu is equal to sine I all over sine R, which will give us refractive index from the question is given to be 1.50. So we have 1.5 is equal to sine 30 all over sine r. Now we can cross multiply from here. If we cross multiply from here, we can now have 1.5 sine r is equal to sine 30. Sine r is equal to sine 30 all over 1.5, which will now give us sine r is equal to sine 30 is 0.5 all over 1.5. Now sine 30, okay, sine r, from our calculator we can have that 0.5 over 1.5 will give us sine r is 0.333. Now we're looking for r. R is equal to sine inverse of 0.33, which will give us that r is equal to R is equal to 19.27 degrees. 19.27 degrees. Therefore, we can now come back here. Since D is equal to I minus R, we can now have that deviation is I, angle of incidence, which is 30 degrees, minus angle of refraction. Angle of refraction is 19.27 degrees. Therefore, the deviation is 30 minus 19.27, and the deviation will give us 10.73 degrees. So that is the angle of deviation. Now, we will not end this lesson without giving you something to do. Please put down this question, and I need the answer in this comment section down below. Okay, the question says, the refractive index of a medium is what? Root 2. The refractive index of a medium is square root of 2. What is the critical angle? From one of those equations, several equations I gave you, you can get this. What is the critical angle? All right. Thank you very much. Thank you for being there with me. We hope to see you in our next video. Please don't forget to hit the like button, share this video, share it with your friends so that they can have access to this knowledge, and then we'll meet